Hi everyone, Ms. Stillman here. This is the homework 4 key. So we start by reading the question and taking in the information. It's a right triangle JKL with KM as the altitude to hypotenuse JL. Please label the 6 and the 15 where they belong, and KM is the X. And we see that that's the altitude. That means if the altitude is being labeled with some sort of information, that's a SAS problem. SAS stands for segment over altitude equals altitude over segment. If you write the word SAS, please also write out the fractions here with the words, so that way you can plug it in and also getting credit for your setup. The segment is 6, the altitude is the X, and the other segment is 15. Those segments each get used once, but the altitude gets used twice. X times X is X squared, 6 times 15 is 90, square root, you get 9.49. You can box it here when you round it, or you can state the side they're looking for and box it. On the next question, I've labeled it. I noticed there's some information on the leg. Look at how that 14 matches up with this segment of 8. Now we're going to put that information into hills. Hypotenuse over leg equals leg over seg. The hypotenuse is X, ln. The leg is 14, use the leg again, 14. X times 8, 8x, and you divide, you get 24.5. The next question, sorry, I gotta put you down for a second. The tape got stuck. Okay, here we go. The next question, I'm going to make sure I draw it fresh for you. It's a right triangle ABC with CD as the altitude drawn to hypotenuse AB. If you notice that's the description that they're giving you, it's a question where the right triangle can be drawn lying on its hypotenuse. And then there's going to be an altitude drawn in. That's the setup we can pretty much use as a go-to diagram when we notice it's probably a hills or a SAS question, because there's a right triangle and an altitude. Okay, so now we have to be very careful with how we label it. The hypotenuse has to be AB, so this is the hypotenuse across from the right angle, AB, and then the altitude has to be CD. Well, we have to decide if C should be the top or the bottom. Well, it comes from the fact that triangle ABC is the triangle we're talking about, and D has to be the part of the altitude that makes the right angles onto the triangle. Now that we have the diagram, we can label AB as 25, DB is 4, and we're trying to find CB. Well, right over there, we're labeling the leg, so we know it's a hills question. After I write the word hills, I write out the proportion. Hypotenuse over leg equals leg over seg. Now we plug the numbers in. The hypotenuse is the whole bottom, which is 25. The leg is the X. The leg repeats as the X. And now the segment has to be the side that matches it. They're on the same right triangle over here. So that's over 4. We cross multiply x squared equals 100, square root. The positive answer is 10. You can box this right here, or you can state the fact that CB is what we're looking for, and that's 10. Okay, the last question is a refresher of how to prove if the triangles are similar. That's a similar symbol for you. So because the position of the triangles is all touching and it's all confusing, we have to rely on the names of the triangles. Notice how I wrote ABC on top of CDB. AB are the first 2 letters, CD are the first 2 letters. They should go in the first proportion, part of the proportion. Then BC is the second and third letter, DB second and third, they go in here, and then AC is the first and last, and CB is the first and last. Now we go to AB and we look at the picture. AB is 10, put it in. Then we want CD, CD is 5. BC, BC is 8. DB, DB is 4. AC, AC is 16. CB, CB is the 8, okay? So now look at how CB is used twice. That's just very interesting because they overlap. Now you put the numbers in and you check them. 10 divided by 5 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Oh, look, they're all 2. Yes, the triangles are similar by side similarity. And just make sure to show the check of the equal ratios. You have to do that for full credit.